Hello everyone. Start from this video, I'm going to talk about the machine control with the sorting station project. So the picture shows the trainer in our lab, right? So I believe up to now you already know what this project does, right? So before I go into talk about more details with the device control with all the equipment, there's one more concept I need to talk about. Namely, it's called the handshake signals, or some people call interlocks. So I'm going to start to talk about those concepts with the drill station example. Even though that's like a continuation from the previous video, but I feel this is more closely related to what we're going to talk about, what we're going to design with the sorting station project. The reason for that is that if you look at this picture again, right? So there are lots of equipment involved with this project, and what we have to do first is to divide the whole project into different stations, different sections, right? So we work on one by one, right? And after that, we put everything together as one project. So namely, so we'll have stations, right? So for example, from the slide on here, this will be our station 1, right? So that has two. Later on, you will see more details, right? Probably already know some of that. We have two cylinders to stop the part from the slide, right? So we can feed them one by one. Right? So that's station 1. Station 2 will use the rotation arm on here to pick the part and load on the lifter, which is station 3. So station 3 will lift it up and shoot the part out on the conveyor belt, right? And then station 4 will move the servo to the correct location in order for the part being sorted and drop into into different bins, right? So as you can see, we designed different sections, different stations separately, and when they need to put together as one project, they have to have some sort of information to exchange, right? Exchange to each other, and in order to work together, right? So that's why the handshake signal is more important at this phase now, right? So I will start with a simple example over here. So for example, we only have a drill station, but this station has a robot. So robot will load and pick the part in order for the drill to process it. So when the part is loaded by automatic equipment, for example the robot, the station logic needs to have the handshakes to enforce the interlock between the equipment. So I'm not going to show the design on the robot. So robot is just like we'll look at from the perspective of the station, from the drill station point of view. So robot will be there'll be an outsider. So robot will just load or clear and the part, right? Oh, I'm sorry. At this stage, still we use the operator to pick, right? So I believe robot pick will be the next example. All right. So again, I'd like to start with a simple example. So for example, robot will load the part and process it, and operator will pick. So with that, we need to have handshake signals between the drill station with the robot. So we need to have two of them, right? So one is let's look at maybe next slide. We'll have a picture to show that. All right. So next slide, we'll have a black box, right? Yeah. So again, so we'll look at from the perspective from the drill station. A robot is just something as external equipment, right? So we'll have two signal exchange. So from the drill station, whenever we home the station with the simple drill, we just need to raise up. Then once we are in the auto mode, we just tell robot, okay, I'm ready for you to load. Right? After that, the drill station just wait for the robot to load the part. Right? Robot will load the part, and after loading, it will move away. Right? You don't want lower the drill while the robot is still loading the part, or otherwise we'll have a collision. Right? So once robot clear off the station, and that will tell the station, okay, I'm cleared. So you can go ahead to process the part. Right? So that's basically those two signals does what they do with the information. All right. So I think better to demonstrate the process. All right. So let's look at the HMI. All right. So right now, station haven't been home haven't been started yet. So you can see the handshake signal over here. Robot to station is clear. Robot is not on the station. You don't see robot here, but the station to the robot is not ready yet. Right? As you can see, we haven't set up the drill station yet. So we put into manual mode. So we are in manual mode. Then we can raise the drill. Right? So the drill will raise up, and it's homed. So you can see here it shows homed. Then once we go into the auto mode, this signal, it's just waiting for the cycle start, right? So once we ready to cycle, you can see this one change to green. So this is the part station tell the robot, I'm ready for you to load the part. Right? So then I'll just use this button to simulate the robot loading. Right? So once robot start to load, you can see here it's load on there, right? Load on the part. But right now the part present is on. You can see part present is on, but we cannot lower the drill. Otherwise, it will have a collision. Right? So we need to wait robot clear. So once robot is cleared, and then you can see here, right? That's the signal robot sent to the station is clear. Then you can see the drill come down and finish the part. In the same time, you can see the ready signal is not ready for the robot. Right? So because robot also need to know if it's ready to go in to load the part. Right? So after we finish the part, the operator will pick. Right? After the pick, you can see the station to robot load ready is green again. It's ready for the robot. All right. So again, robot load. Once robot load, and the station will not process until robot become clear. So once robot clear, then the drill come down. Right. So you can see here the drill come down and process the part. And just wait for the operator to pick. So once the operator pick the part, and then it's ready to load again. Okay, so this is just a basic, simple example to introduce the handshake. So we'll look at different equipment to work together. Right. So with the drill station and the robot, they have to work together. Right. So this is one example I want to demonstrate. Right. So then let's look at how do we implement that with the those two handshake signals. As you can see here, obviously we need some of the new tags. Right. So there's one extend permit. Right. So in order for the drill to come down, so we need to give the drill tooling like a permission in order to lower it, right? So how do we represent that? We have to use the new tags, and so then where are the tags? So on the next slide, I show you a little bit. All right. So before I show you this UDT tag before, right? So by that time I didn't go into detail over here. You can see we have a data type called the cylinders, right? So the drill on the example I just showed you is we don't have a clamp, but next one we'll have. They are both the type of cylinders. So with cylinder type, actually I already include those
tags in there. So you can see here there's a retract permit, extend permit, right? So in this case, we only use the extend permit. We don't use the retract permit, but it's there available for us to use, right? So all the tags within the UDT, like for example, we also have a memory bit. If you don't use it, it's okay. It's sitting there, right? So, but in some situation we do need it, so we can just grab the tag from the existing UDT, right? Just that you know that. So if you have other things you need to add on top of that, you can add member or even add UDT. So for example, you can see here the logic I show you on the simple drill example is that we need to have a drill extend permit, right? So that part is waiting for the robot. Again, we are not including the robot logic into our design. I just use this as example, right? So that'll be the push button I pressed. So whenever the robot is clear, so that will energize the this extend permit bit. So how do we use this bit? So we just insert that into existing logic, right? So as you can see here, before this video I already demonstrate two different type of design. One is called sequence bits, the other one is called the step logic. All right. So as you can see, if we use sequence bit, so we'll just insert this extend permit into the auto mode branch, right? So we don't need a permit for the manual, right? Manual operator is controlling the part by the doing that observation, right? So that will prevent that. But once we are going to the auto, we need to have this permit insert into there as one extra condition. So same thing for here. So with the step logic design, right, you obviously have different steps in order to extend the drill as the result. But in order to extend the drill, you need to have this actual permit from the station routine, right? So that is just let you to have some basic idea, right? So we don't have to invent a brand new logic. So we just use what we designed before, right? So those are the logic we have before. We just insert new conditions to make some modifications on the existing logic, right? So we don't have to reinvent the wheel, right? So that's what we'll focus on, right? So let me just introduce another example. This example will be a little bit more complicated, right? Not simple as the previous one. So this one, we have the robot to load the part, not only drop the part, and also we use robot to pick the part. So again, I'm not worry about the design on the robot part. I just use those buttons to simulate that. And then I have the timer as delay, so they have a 5-second delay to simulate the robot operation. Right. So then we have the robot from robot to the station to tell the drill station I'm at home or I'm at dropping, so drop the part in here, or I'm going to pick the part from there. So it just basically tell the drill station where is the robot, right? So then we will look at the drill from the drill station point of view, the logic. How do we process that? So same as before with manual, we can home the station. Once we go into the auto cycle start, we will do the close clamp, right? So close clamp and drill come down, but we have to consider with robot involved, right? So the handshake signal is that we have to let the robot know, okay, I'm ready for you to load, right? So then the other signal is, maybe I can show you next slide. All right, so that's more clear on there. So let me remove all that, then go to next slide. Yeah, so that's more clear on that. So let's look at the sequence. All right, so when robot at home, so tell
the drill station, I'm at home. And then once the station homed, we tell the robot, okay, I'm ready for you to load. Right? Then the robot start to load the part, going to the position to load, and at that time we will have the clamp to close. So robot just put there, and clamp start to close. Once clamp closed, the part is fixed into position, right? So then tell the robot, okay, my clamp is okay now. So the robot part, robot maybe just open the gripper and load the part on the station, then go back to home. And then tell the drill station, I'm at home now, so you can start the process. So now the drill can come down, drill the hole. Right? Once finish the cycle, part ready, tell the robot, okay, you can come in to pick. So you can see this is sort of a back and forth, right? So when robot get into the part, and the clamp will open, right? So you remember you have the clamp. You can work with the robot now, right? So once the clamp open, the robot can pick the part away, right? So as you can see, this is more complicated handshake signal now, right? So let's just see the demo, right? So let me just show you on this part. All right, I have to go to different screen. All right. Okay, so this is the demo interface. All right. So right now it's in the home and auto cycle start. All right. I believe we're ready. Let's try it. We're ready to press the cycle start. All right. So once we cycle start, as you can see here, so the station to robot load ready is green. It's on. And from the robot is at home. Right, robot is at home. So again, I'll press the button to simulate the robot's situation. So robot will go into the drop. So then you will see the timer start counting for 5 seconds to process, to simulate the process. So after 5 seconds, you can see the part. You can see the part is being loaded on here. Right. So this part I don't have the animation to show the robot here, but you can see right now robot is loading out here. Right. So then the clamp close. I think I missed that. The clamp start to close, right? And then after clamp close, robot should go back to home, right? So then we'll use this button to go home. After 5 seconds, before was at the drop, right? So right now robot at home. So you can see the drill come down. Drill come down with the robot clear. Then the drill goes up. Once drill goes up, it will stay there. And the clamp still closed, right? Now it's ready. You can see here, station to robot part ready. It already finished, right? So then we simulate robot going to pick. So robot will go in to grab the part. So once grab the part, the clamp, you can see here the clamp open. Right. So if your clamp still closed, you cannot move the part away. Right. So once the clamp open, we can let the robot to go home. Right. To clear that. Right, before was at the peak, right now it's at home. Right, so everything is clear now. So we're ready to go to the next part. As you can see here, it shows two robot. So station tell robot, I'm ready for you to load. Right now, robot is at home. So once I press this to drop, 5 second delay, then you will see part being loaded on here. Once the part pattern is on, the clamp will start to close. Right. So in order to precisely or to clamp the position, clamp the part in position. Right. So I'm gonna let the robot load. The part pattern is on, should be on now in 5 seconds, and then the clamp. You can see the clamp start to move, close on that. Right. So that's the clamp close. So right now you can see robot tell station I'm at a drop. Right, I'm not cleared for you to go ahead. So now robot, if go to home, after 5 seconds, robot will show at home. Once robot at home, the drill will come down. Drill come down to process the part, and then automatically go up. Right, so the drill station doesn't need to wait for anything. Right, so go up right away, and then the handshake signal to the robot is the part ready. Right, part is finished, and then robot going to pick. So robot right now is at home. After 5 seconds, you will see at pick turn on. Right, so after that, the clamp will open. Right, you can see clamp open. So robot right now is clear to move away. Right, so that's the second part. Right, so then let's look at the detailed design. So again, if you look at the program design on this slide, it's not like a brand new logic. It just use what we have before. Right, so remember before we only have the let me see if I can show you on the program. Right, I believe this is the program. Let me open up. All right, so we need to look at the routine 141, 142, 141 is here. Yeah, so this is the so you should be familiar with this before, right? So this is the mode, right? Then this is the cycle, and then before, remember I talked about the handshake. Before was empty. Right now it has logic in here. So that's where we look at it. All right. So it's kind of small, right? So that's why maybe we should switch back to here. All right. So handshake to the robot based on the station status. Right. So one thing with the station modification is that before we make the request, we need to make sure the robot is at home. Right. So that's why we insert again. We just before we don't have this condition. Once we have a robot, we just insert this into existing logic, and then with the handshake to the robot. So as you can see, once we cycle start, we don't have a part. So we tell robot, okay, I'm ready for you to load. The next one, drop OK, is that depends on different steps, right? So if you look at your tooling steps, you need to find out when is the time for the robot to load, right? In this example, is that when we at step 2, but before step 3. Right, so this is just depends on your existing logic. So you pick the signal to energize this, and then to robot part ready is that again different sequence, right? On the sequence 4 before sequence 5, before step 5, we already finished the part, and then ready for the robot to go in to pick it up, and then part present and step 1, 2. On here you have the PickOK. All right. So we also have the we have to receive the handshake signal from the robot. Then we pass to the tooling with the permit bits. All right. So next slide will show the details, but from here you can see when we have the robot signal come into the station, we energize the tooling, like over here. So we are at the drop. So you just saw the demo, right? So when robot is at the drop, that means robot already load the part into location. So the clamp ready to retract, close the clamp to grab the part, right? The other signal is that when robot at home, so the drill will be allowed to extend to come down.
The other one is that if robot at the pick, right? So we finish the part, the clamp need to open, but before the clamp open extend, we need to make sure robot is at the pick position, ready to move to grab the part, right? So again, briefly, let's look at the next one over here. So from this slide, if you look at here with the routine 3 tooling, right? So that's where we have the real output, right? The clamp, the drill output. So for each tooling movement, we have to look at if we need to have the permits, right? So over here with the clamp retract and clamp extend, obviously we need different permit bits, right, from the previous slide. And then with the drill retract, as you can see, there's no permit bits, right? From the demo, if you remember, when drill finished the hole, it would just automatically go up. There's no permit get involved on there. But when you have the over here, this is a clamp, and this is the drill extend, right? So that's different permit, right? The clamp extend also have a permit, right? So basically 3 of them, only one doesn't need the permit bit, but the other have the new condition involved, right? So by using this demo, I'm just trying to let you to understand. All right, so we need to have the different signals to exchange the situation like this back and forth, right? So how do we implement them? So we just need add new conditions into the existing logic. All right, so if you have this concept, this idea, we're ready to go into the sorting station specific examples now.